No disrespect to my pops when Dixie just wasn't paying. My mama did what she could. As a kid, I heard patience was a virtue. With the first day of school, those last year shoes could hurt you. Stains on those Paco jeans, but long on tire commercials. So they talk and they laugh. I swear I get back that them double RLs is hard. And my G-Star, they got slack and we grown.
Hey friends, it's Louie, and I'm coming at you again with the Astrophysics for People in a Hurry analysis series. In this video, we're going to go over chapters 4 and chapter 5. In these two chapters, the density of the information has definitely increased. And so I'm going to kind of just really kind of focus on what things say and then just touch on how it impacts how I think. And I'm assuming it's going to keep getting more and more dense as the book starts getting deeper into everything and starts making the connections. So anyways, chapter 4 is called Between the Galaxies, and he starts off by building this perspective that we are in this galaxy, but there's billions of galaxies, and the reality is that the nearest galaxy to us is 600 light years away, meaning there's a lot of space between the galaxies. And then he goes on to say that the most interesting stuff is in those spaces. And so on page 64, he says, aided by modern detectors and modern theories, we have probed our cosmic countryside and revealed all manner of hard-to-detect things. Dwarf galaxies, runaway stars that explode, million-degree X-ray emitting gas, dark matter, faint blue galaxies, ubiquitous gas clouds, super-duper high-energy charged particles, and the mysterious quantum vacuum energy. And so obviously he goes on for the remainder of this chapter to discuss those things. One of the things that I was pretty fascinated by was dwarf galaxies. He was explaining that dwarf galaxies are just like smaller galaxies. They just have, instead of having billions of stars, they have like millions. But the interesting thing is that they outnumber normal galaxies 10 to 1. And in a way, bigger galaxies eat them. So they'll kind of be floating around doing their own thing, and then they'll be like kind of orbiting a galaxy like a planet orbits the sun, and yeah, I thought that was a wild concept. And dwarf galaxies are still mysterious to us because there's not enough light within them for us to necessarily see them. And this whole concept of what we can see and what we can't see is really kind of dictating where that forefront is in present day science. And then the next thing he talks about are quasars, and he states on page 70, quasars are super luminous galaxy cores whose light has typically been traveling for billions of years across space before reaching our telescopes. As extremely distant sources of light, they make ideal guinea pigs for the detection of intervening junk. Sure enough, when you separate quasar light into its component colors, revealing a spectrum, it's riddled with the absorbing presence of intervening gas clouds. So what they do is they take the light, they break it up into a spectrum, and based on that spectrum of light that you get, you can thus determine what that light is made of in terms of like what materials make it. Is it made of hydrogen, oxygen, carbon? Like, what is it made of? It says every known quasar, no matter where on the sky it's found, shows features from dozens of isolated hydrogen clouds scattered across time and space. So what he's describing right now are these ubiquitous gas clouds, and the reason that they're interesting is because as we're studying the quasars, we're realizing that these gas clouds are present, but these gas clouds are acting like a lens. In a way, they magnify, distort, or split into multiple images the original light of the quasar. But that makes it fascinating because, like, if we're looking off into the distance in a particular moment in time and space, there's this hydrogen gas cloud that's allowing us to see something that's like way farther away and maybe like to the left or some shit. And like that, because that gas cloud is there in that moment, as we're looking in that direction, we're able to see the Quasar, which is billions of years old. So just kind of a very fascinating perspective, you know, to run the mind through. And then the last thing that he kind of touches on is these cosmic rays. And I'm just going to kind of read what he says because it's kind of a dense concept, and I think there's a lot more associated with it philosophically, based on what was found with science. Okay. From the Department of Exotic Happenings, intergalactic space is regularly pierced by super-duper high-energy, fast-moving charged subatomic particles. We call them cosmic rays. The highest energy particles among them have 100 million times the energy that can be generated in the world's largest particle accelerators. Their origin continues to be a mystery, but most of these charged particles are protons, the nuclei of hydrogen atoms, and are moving at 99.99999999999% of the speed of light. Remarkably, these single subatomic particles carry enough energy to knock a golf ball from anywhere on the putting green into the cup. And then he kind of ends the chapter with this last thought. Perhaps the most exotic happenings between and among the galaxies and the vacuum of space and time is the seething ocean of virtual particles. Undetectable matter and antimatter pairs popping in and out of existence. This peculiar prediction of quantum physics has been dubbed the vacuum energy, which manifests as an outward pressure acting counter to gravity that thrives in the total absence of matter. The accelerating universe, dark energy incarnate, may be driven by the action of this vacuum energy. Yes, intergalactic space is and will forever be where the action is. Like, Neil, you gotta stop turning my brain into a puddle of goop, okay? It's just, I spend my days going in and out of existence, and, you know, I read your book, I read 2 chapters, and the rest of the day I'm, you know, spent trying to gather up this goop and put it back in my head, you know? It's gnarly, man. But at this point, I just need to get through this book so I don't lose my brain in the cracks of this deck. So yeah, you know, these cosmic rays, some of the most highly charged particles, is connected to dark matter. It's where these highly charged particles manifest through dark matter, and dark matter is 85% of all that there is in the universe, but we can't see it or detect it. We only can feel it. You know, it's just like, science, why are you describing God? Like, when was the last time someone didn't describe God as something that just is, that you can just feel but you can't see? Like, come on, man, this is a beautiful time to be a human being. Science, religion, and philosophy are all looking at the same horizon. And what's really dope is that in our lifetime, due to technological advancements that are happening at an exponential rate, we're going to be able to see that shit. So, 2017, great time to be a human. Cool. And so, yeah, guys, this video is probably going to be long. This shit's so dense. I'm going to be diving into dark matter in Chapter 5 because the name of Chapter 5 is Dark Matter. I thought it was very interesting that... you know, I've been having this like concept that dark matter is like this God force, and in numerology, like 5 is usually the representative presence or number of God, and chapter 5 is dark matter. So just like, wow, crazy coincidence, universe, you're hilarious. So chapter 5 is obviously talking about dark matter. Obviously left off chapter 4 with this like huge idea that dark matter and these cosmic rays are some sort of unknown force. And so here we go into dark matter. So he starts talking about this this scientist who goes by the name Zwicky. His last name is Zwicky. And he was a scientist in 1937 who studied the Coma cluster of galaxies to find the average velocity was shockingly high. So essentially he was studying a cluster of galaxies, and like how I was kind of explaining how dwarf galaxies kind of go around normal galaxies. Well, normal galaxies go around each other in this weird kind of like ever-flowing way, and the reality is that there's an escape velocity to anything. There's an escape velocity to our planets, there's an escape velocity to galaxies, and the escape velocity represents the ability for an object to be released from the gravitational pull of whatever is holding it there. So, for example, like if the Earth sped up a little bit, it gained more, energy in terms of speed. We would break the gravitational pull of the sun and, be thrown violently into the vastness of, the galaxy, which would probably not be a good time. But what he found while he was trying to study these velocities, and the reason that he found they were shockingly high, and the reason that was shocking was because he figured the escape velocity was such based on the gravity of that cluster, but then he found that they were actually moving a lot faster than they should have been, right? Like the science didn't, bless you, Picasso, the science didn't make sense. He was confused because essentially, based on the fact that of his studies and his science, the Coma cluster should fly apart. It shouldn't exist. But it's been together for 10 billion years. And that is the longest standing unsolved mystery in astrophysics. We still can't understand it. It's really interesting because he was kind of mentioning how the only thing that they can explain is the presence of dark matter. Though the galaxies are traveling beyond the escape velocity, they're still together because of the presence of dark matter. This dark matter is a wild thing, guys. Holy fuck. So he kind of drops that in just to make you understand, and like he kind of ends it with like that's the longest standing unsolved mystery in astrophysics, which I find fascinating. Being a human being alive in 2017 and understanding where the greatest minds on the planet are still like dictating as a mystery, like understanding where that is, it's fascinating. It's fucking fascinating. And if you don't think it's fascinating, man, please don't have a conversation with me. It's just not going to be worth my time. So I'm going to read a couple quotes about dark matter that he talks about in this chapter, and I'm going to just kind of he says everything, and then after I read all this stuff, I'll say what I feel. But I'm just going to go through these quotes now. On page 82. He says that cosmic dark matter has about 6 times the total gravity of all visible matter. Cosmic dark matter has about 6 times the total gravity of all visible matter. So all that we can see visibly, all the forces acting on each other, is 1/6 the amount of energy and force that's being applied by dark matter. God. That's so funny, dude. All right. And so, back to this like weird quantification. In our galaxy, everything that's not the sun, so all the planets, all the stars, everything that's in our galaxy other than the sun adds up to less than 1/5 of 1% of the sun's mass. Our galaxy is the sun. Our sun is like 99% of our galaxy. That's freaking wild. Oh my god. I don't even know if I'm gonna be able to get through all these facts, guys. This is nuts. Okay. Okay. Then, so it's been said that dark matter is not matter, but we can feel its gravity, right? So now he's explaining why it's not declared matter, and the reason that dark matter isn't matter is because it doesn't participate in nuclear fusion. So hold on, let me get to this here. Okay. Yeah, I'm gonna read this because this is just like a wild couple paragraphs. More direct evidence for the strange nature of dark matter comes from the relative amount of hydrogen and helium in the universe. Together, these numbers provide a cosmic fingerprint left behind by the early universe. To a close approximation, nuclear fusion during the first few minutes after the Big Bang left behind 1 helium nucleus for every 10 hydrogen nuclei, which are themselves simply protons. Calculations show that if most of the dark matter had involved itself in nuclear fusion, there would be much more helium relative to hydrogen in the universe. From this, we conclude that most of the dark matter, hence most of the mass in the universe, does not participate in nuclear fusion, which qualifies it as ordinary matter, whose essence lies in a willingness to participate in the atomic and nuclear forces that shape matter as we know it. So essentially, what he just kind of stated was that all matter must perform atomic and nuclear forces for it to be matter. Then it says, detailed observations of the cosmic microwave background, which allow a separate test of this conclusion, verify the result. Dark matter and nuclear fusion don't mix. Thus, as best we can figure, the dark matter doesn't simply consist of matter that happens to be dark. Instead, it's something else altogether. Dark matter exerts gravity according to the same rules that ordinary matter follows, but it does little else that might allow us to detect it. I'm fascinated by this dark matter, guys. I can't even I said this in my podcast. You can go check it out. I'm pretty sure it was podcast 3 or Narnia 3 or 4, maybe. I don't know. It's one of the early ones. It's called Dark Matter. I'm pretty sure. Anyways, ever since Neil's been talking about dark matter with Joe Rogan on his podcast, I'm completely engulfed in this idea that dark matter is the God force, man. It's the thing. And once we can understand dark matter, once we can study it through our technological advancements, consciousness is going to change. And that's why I'm so fascinated with this. Guys, I'm not a scientist. I'm fucking not. I don't really understand this shit all the way. I'm not Neil, you know what I mean? But one thing that I do love is exploring my thoughts through this shit. So, you know, just take that into consideration. This is just my philosophical interpretation of science. Like, I'm not a scientist. Thank you. Okay, and so he kind of puts an interesting illusion, or an interesting, yeah, whatever. What we know is that the matter we have come to love in the universe, the stuff of stars, planets, and life, is only a light frosting on the cosmic cake, modest buoys afloat in a vast cosmic ocean of something that looks like nothing. Man, you know, I mean, I don't know if Neil necessarily, I'm pretty sure Neil wrote this thing. Even on Joe Rogan's podcast, man, he's just got a really kind of beautiful precision with his language and his words, which I think helps him describe this shit so well. So yeah, I'm gonna say this again. You should go check out that Joe Rogan podcast with Neil talking about this book from like 2.5 months ago. It's fucking awesome, and it's a great prelude to this book. So now that you saw this video, you're gonna go and you're gonna order this fucking book and read this for your goddamn self. But you're also gonna go watch that podcast. It's a 2.5-hour podcast. You're gonna watch it while you're driving to and from work as a prelude, because it's a good prelude. Okay, and then let's see here, and then on page 89, it's interesting. He gets a little philosophical here. He gets a little like, and Neil doesn't really do that. You know, I don't think his brain was necessarily meant to do that. He's so gifted and blessed with the ability to explore the reality that he like even says in the podcast with Joe, that like he even doesn't really spend too much time like thinking about that stuff. He just thinks about what can be studied, and that's like really dope. Thanks, Neil. But this was kind of like a cool thing. The worst that can happen is we discover that dark matter does not consist of matter at all, but of something else. Could we be seeing the effects of forces from another dimension? Are we feeling the ordinary gravity of ordinary matter crossing the membrane of a phantom universe adjacent to ours? If so, this could be just one of an infinite assortment of universes that comprise the multiverse. Sounds exotic and unbelievable. But is it any more crazy than the first suggestions that Earth orbits the sun? That the sun is one of 100 billion stars in the Milky Way? Or that the Milky Way is but one of 100 billion galaxies in the universe? No, it's fucking not, man. Like I said, we are in a wild time to be a human being, and we are able to understand that our forefront, you know, it used to be like Earth used to be our ceiling. You know, we human beings at one point didn't understand that there was more than this planet. And then we started to understand that there was like all these planets and stuff. And for a while, we thought that everything fucking was going around us. You know, like that was the reality of what people thought. And now in 2017, the reality of what we think is that there's multiple galaxies within this one dimension, all being fucking held together by dark matter, this god force of some fucking nature. And all of that is just happening in one dimension of this multiverse. And the dark matter itself is actually the forces of the other universes that's all happening at once. We're in the soup, man. Like, we used to think we were on a planet, and then we thought we were in this dimension, but we're in this, like, cosmic, multi-dimensional soup. Fucking nuts, dude. It's nuts. If you don't believe me, don't fucking watch any more of my videos. You're just not on the right wavelength. So, alright. So, yeah, I'm gonna end with his conclusion of the chapter. I'm gonna make a little brief mention here of neutrinos. Neutrinos are these particles that carry energy but don't impact matter. So they're kind of like the opposite of dark matter. They are matter, but they don't impact matter. Whereas dark matter is something that we don't know, and it impacts matter. It's interesting because he brings them up, neutrinos. Essentially, he explains that like millions of neutrinos are flowing through me right now. Like right now, they're coming from the sun. They're shot out consistently. Like they're going through the Earth, but not impacting the Earth. And yeah, that's just the reality. So it's mentioned in the conclusion. So I figured I'd bring that up for you guys. Okay, so dark matter's effects are real. We just don't know what it is. Dark matter seems not to interact through the strong nuclear force, so it can't make nuclei. It hasn't been found to interact through the weak nuclear force, something even elusive neutrinos do. It doesn't seem to interact with the electromagnetic force, so it doesn't make molecules and concentrate into dense balls of dark matter. Nor does it absorb or emit or reflect or scatter light. As we've known from the beginning, dark matter does indeed exert gravity, to which ordinary matter responds. But that's it. After all these years, we haven't discovered it doing anything else. For now, we must remain content to carry dark matter along as a strange invisible friend, invoking it where and when the universe requires it of us. Like, he just built the alliteration. Like, he just did it. We must remain content to carry dark matter along as a strange invisible friend, invoking it where and when the universe requires it of us. God. So yeah, guys, I hope you dug this analysis. You know, I kind of did my analysis like as I was going through the quotes and as I was going through it and stuff. But you know, this book's getting fascinating, as you can see. So like that was the end of chapter 5. And you know, we're probably at like a third of maybe a little over a third of the way through the book. Yeah, chapter 6, dark energy. I'm very fucking excited. I'm very excited, guys. So yeah, chapter 6 and chapter 7 will probably be coming at you soon, or you can just chill and wait and it'll probably come through in the next video. Hit subscribe. Love you guys. Peace.
Posters up on the block, baking soda with the pot. The baby mama